A conveyor belt is moving with velocity 2 meters per second. Sand is allowed to fall on this belt continuously at a rate of 1 kg per second. Then what is the force required to move the belt with constant velocity 2 meters per second? In previous problem we discussed that no force is required to move the body with constant velocity. Can we apply the same here? No, we can't apply. Why? Because we have to move the conveyor belt with constant velocity, but the mass that falling on the belt is not constant. The sand is falling on this belt continuously at a rate of 1 kg per second. That means mass is varying. When mass is falling on the belt, automatically the velocity will be decreased because of this excess mass. To carry it, again we have to apply an external force. In this case, the force required is nothing but V into delta m by delta t. That is velocity into the rate of change of mass. And in this problem it is given the velocity is 2 meters per second. The rate of change of mass is 1 kg per second. Therefore, force is V into delta m by delta t. This is equal to 2 into 1, 2 kg meter per second square, or this is 2 Newton. We take another problem. A ball of mass 0.5 kg moving linearly with velocity 5 meters per second initially hits a vertical wall and rebounds with same velocity, and the contact time is 0.1 second. Now in this problem, what is the initial momentum? Mass is 0.5 kg and it is moving with velocity 5 meters per second. Therefore, the initial momentum is 0.5 into 5, 2.5 kg meter per second. Now what is final momentum? Final mass 0.5 kg only, there is no change in mass. Then what about velocity? It is 5 meters per second but opposite in direction. We are considering the initial motion of the ball is in this direction, hence we have to consider this is positive, and in this direction we have to take negative. The final velocity is minus 5 meters per second. Therefore, the final momentum is 0.5 into minus 5, and this is equal to minus 2.5 kg meter per second. Now what is the change in momentum? Change in momentum is nothing but final momentum minus initial momentum. This is minus 2.5, this is the final momentum, minus 2.5 minus 5 kg meter per second. The change in momentum is in this direction. What does it mean? Due to this vertical wall, force is acting in this direction. Therefore, the body changes its momentum in the same direction. Now what is force of impact? Force is change in momentum by time. This is minus 5 by 0.1. This is equal to minus 50 kg meter per second square, or minus 50 Newton. And this is the force on the ball due to wall. If I want force on the wall due to ball, it is 15 Newton. Force on the ball due to wall is acting along this direction. Both are equal and opposite. You consider any action, there is always opposite reaction. This leads to Newton's third law that we discuss later.